couple of years ago, one of my clients asked this question to the audience. So if you ask 5 process engineers, what is the production for today, how many answers do you get? And I'm asking you the same question. 5, 6, 5, 9. And that is because it really depends who you ask, what kind of data they're using, the version of the Excel spreadsheet that they're looking for, and then who they ask about the results and, try to come up with a number for you. So, but the thing is, it doesn't have to be that way. It is possible to have one single answer that is actually correct. And what I'm going to show today is how using the Pi system and Sigmafine we can do that. So this is my agenda for today, and first I'm going to talk about digital trends and the challenges that we have with these digital trends. Bernard and Massimo, they already touched on these topics earlier this morning, so I'm going to probably repeat a couple of the things they already said. And then I'm going to talk about customer success stories that will show the progression of the analytics that I'm going to show to you. And at the end, I'm going to talk about the roadmap from OSIsoft about the Pi system, what we've done in this past year, so that you have an idea of where the data infrastructure is going, and specifically how the Sigmafine clients will benefit from it. So first, let's start with the big data challenge. So we heard about IoT, Industry 4.0, big data. And this is a problem because we have the capability to gather more information. A statistic says that by 2025, we're going to have 3.3 billion machine-to-machine connections in the world. And this equates to yottabytes of data. So if you want to have a measurement of what a yottabyte is, let's say that a grain of rice equals a byte. So a yottabyte of data is like having an Earth-sized rice ball. So this is a lot of information that we need to make sense of. And we need tools to be able to do that. And for that, we use the analytics. So the analytics, Gartner, they showed this a couple of years back, that they go in a progression. And many of you are doing this on a day-to-day basis. So the first one is the descriptive analytics. So these are good because they tell us what happened, right? So if you have a trend, you can look at the history, see where things were, and figure out where things are going, right? Based on your feeling or your instincts. Then we have the diagnostics. The diagnostics will help us identify why things happened, right? So this could be drill down type of functionality, being able from a dashboard, see a KPI, drill down and see what's happening in real time, and look at the historical data with trends and whatnot. And this is very informative. This is very good. This will help you find some answers. Then the next one is predictive analytics. So with predictive analytics, what you're trying to do is you're trying to find, so with the information that I have right now, and based on my knowledge, what could happen next? And for this, we're going to use some more advanced analytical tools. For instance, I will say the Sigmafine can be used to do some predictive analytics based on the reconciled and the historical data that you already have. And it's going to help you anticipate to the issues and try to come into your process, fix the situation so that the predictions or the results will be better in the future. And the last one is prescriptive analytics. Prescriptive analytics has to do with, well, yes, predicting what is going to happen, but also finding the most effective way to make that result happen. If you're looking for a particular quality threshold or particular quality target, how do we make that quality target happen based on what we have today? And for this, we can use tools like machine learning or artificial intelligence to find the most cost-effective way or the most efficient way if you're looking at performance or yield. So this is the progression of the analytics, and the use cases that I'm going to present will cover this pattern. Very well. So the first one is Dow Corning. And all these use cases that I'm presenting are customers of PIMSoft and OSIsoft. So they're all using Sigmafine and the Pi system for the solutions. But let's start with Dow Corning. And Dow Corning, they were having an issue because they were already doing production accounting and some yield performance calculations. And like our friends from Reliance mentioned, you know, it took a lot of time. They were doing some of it manually and whatnot. So the first thing that they said, well, let's use what we have or the knowledge that we have today and put it in an automated system so that we can leverage our knowledge, but use a more modern tool that we can use to connect directly to our ERP, that in their case was SAP, right? So they wanted to get rid of all the pointed solution and all the Excel spreadsheets that they were trying to use, and have a solution that will be easier for newcomers to adopt, because that was also a big problem for them. How do we train new engineers, or how do we really leverage the engineering power that they had at their hands? So, of course, like many of you, they started with standardizing a naming convention for the different operating units. They built a model, an asset-based model in AF, and they also did it in a way that they had a very comprehensive workflow of the data. So they automated this way of doing the data reconciliation. So I know that you know that Sigmafine has a process, right? Validating the data and running the reconciliation and whatnot. But they were able to do this automatically and with no intervention from the process engineers. So they let the system run, and they only put together some dashboards like the one I have here on the screen, where you can see, well, I cannot point to it, but they are looking at this dashboard just to validate that the reconciliation information is actually run it like it should. And whenever there is an outlier, then they go in and they actually look into the details, see what's happening. Maybe there is a sensor that it's missing information, or something happened within that day that they need to go and take action. And for those, you'll probably see little notes on the top of the trends, and that's because there is some manual intervention for that particular case. But in general, these are cases that are running unattended. So having a model, being able to validate the data before they publish, this is streamlined the data flow into SAP, which is what they were going after, and they were able to reuse some of the RFCs that they already had in place with SAP. So this is what the data workflow looks like for Dow Corning, and you can see it's very, I thought it was a very clean way the way that they presented of how they start. Well, we are collecting the data, we are putting the data into the model, we create the case, and we continue and so on. There are some iterations in case there are some discrepancies that they need to look at, and at the end they finalize the case, publishing the results into SAP, which was the end result. So the improvements that they got was, of course, the automated flow and integration with SAP, an easier way to look at the data flow, and this allowed them to identify critical pieces of measurement within the process. This also allowed them to justify the buying of new measurement that they needed for their model. And the visibility of the financial impact of the process is now possible because now they have accurate information and it's easier to do. And also, just being able to pass this knowledge into newcomers into their facilities. So the next one, and going into in the progression of the analytics, now we are talking about the prediction of quality properties. And for this, I'm gonna use the example of ENI Versalis, and this is an aromatics plant based out of beautiful Sicily in Italy. And their main issue was that the expected yield was not consistent with the current yield that they had at the end of the month. And they only knew this at the end of the month. So that was not good because there was not much they could do. They knew they had a problem and they tried to correct it, but because it's 30 days old data, it was a hit and miss. So what they decided to do was, okay, so they had Sigmafine. They said, how can we use the quality properties of our receipts so that we know what's going into the aromatics plant? They did a model, a component tracking model, using the tanks that are receiving the different components from either a pipeline or the ships docked in the harbor, and they are checking the quality information for each tank. And what they are looking for are the content of the volatile organic components, and these 5 VOCs are benzene, toluene, xylene, ethylbenzene, and styrene, along with some alkanes that go from butane to decane, and the diene and bromine number, which basically tell them the content of the olefins that help to predict the performance of the distillation process. So that's why this is important. This is what they were tracking. They had the history. They put it into the composition tracking model, and along with the flow meters, the tank levels, and this lab data, they are able to. They found a correlation of the different components with the performance of the plant at the end of the case. So basically, they are using the tanks as a blending mechanism for the feeding input into the aromatic plant. And they are, as you can see here in the model, they are reconciling these 5 measurements that I have on the right hand of the tanks with the measurement coming into the aromatic plant. So at the end of the day, after going through this exercise of putting the model together, tracking the composition, tracking the different percentages of the components, and doing the data reconciliation for the composition tracking in the composition tracking model, they found very strong correlations between the benzene in the tanks with the C6 and C8 contents in the contents of the production. And you can see here, I have a blue box where you can see that there is a period where there was some model tuning. The green bar, and I hope you can see it. I can see it pretty clear here, but I hope you can see it too. The green bar, this is telling us, okay, these are the ranges that we should be operating within, right? So close to 1, it means that the model is predicting the yield as it should, and what they are trying to do is keep all the different components or all the different lines or the trends that you see there within that range. So at the beginning it was difficult to do because they were still figuring out what is the composition that we have in the tanks, what is the model, what does the model look like, and then you can see there is a spike in the middle of the trend. That means this is a non-steady state event. So there was actually a shutdown, and that's why, the model is giving you not accurate information. So there is a lot of benzene, and then there is no correlation there, which doesn't make a lot of sense with the previous time. But then once they come back online, you can see the quality and the yield are within the ranges that they were looking at. So now they know that the model is actually predicting the yield as they wanted, as they were hoping for, or as they wanted to. And you can see this happen within a month. All these points here are a day-by-day yield or prediction of the quality and yield, which is something they didn't have before, and now it is possible, and they have a model that is accurately predicting the yields for the plant. And this has other repercussions. So now they know what's going into the aromatic plant, so they can have a better performance of the plant itself. They can be smarter on the logistics, what kinds of receipts they're receiving in which tank based on the composition that is already in the tank. So at the end of the day, it has a financial impact in the operations of the plants and the logistics of the receipts. And then we have this use case from MOL. This is, and so they do downstream, And actually, MOL was doing pretty well. They've been using Sigmafine for a few years, and Sigmafine is part of the equation. So this is going back to what Massimo mentioned in the morning, that there are some tools that are complementary to the use of real-time data and reconciled data, and this is exactly the case of MOL. So they have this goal of using a 50 plus different grades of crude within their basket and being able to process all, that variety. And they want to do this because it promises big gains, financially speaking. Just having the flexibility to move from one grade to another gives you the flexibility to buy cheaper crude to be able to process. So, but this also has some challenges. And the challenges that I'm going to focus here are two. One is corrosion in the equipment, and the other one is just safety. So, in the delayed cooker unit, they were having steam eruptions that are very dangerous if they go out of hand. So, they wanted to integrate this again with their maintenance module from SAP with predictive maintenance and just make it safer and better for the process to run. So, like I mentioned before, these are some of the pros that you can see at using a bigger variety of crude. So, discounted price, the estimated benefit by using 10% alternative crudes is about 10 to 11 million per refinery. They have 6, and this is a big gain if they are able to manage it. The problem is that they have no idea what's going to come out of using different crudes, right? So they needed more advanced analytics to help them know what was the effect of using a different kind of grade or a different mix of grades in their process. And here I'm showing a architecture, or a very high-level architecture of all the tools that they are using. So as you can see, this is not one single solution working to give them the answers they have. It's a combination of several of them. Sigmafine is doing the yield accounting, mass balance processes, but they have SAP for production costing, and for maintenance. They have the PI system at the heart of it, collecting the data from all the different sources, but also sending that data into machine learning. So these are the solutions they came up with. So first, they had a model. In the model, they were able to configure some of the analytics for the corrosion analysis. And in the next slide, I'm going to show you what that looks like. And for the steam eruptions in the delayed cooker unit, or the DCU, using machine learning, they realized that they had to have more than 10% of the residuals from the hydrocracker to be able to be on the safe stage. So, and I'm going to show you a little bit of how that happened too. Right, and of course, user notifications. They want to use the notifications to trigger the workflow for maintenance into SAP. High temperature, hydrogen corrosion modeling. It all began in AF, and we know that the HTHC depends on the metallurgy, so the type of pipeline that they have, the temperature, the partial pressure of the hydrogen, and the length of exposure. So all this is information that they are collecting real time. They put in the equations into AF, and AF is able to quantify or to calculate the HTHC number currently. They have some high limits and they have some low limits. And whenever the threshold is met, they can send out a notification to start a maintenance workflow. Also, this information or these events, whenever they are hitting a high limit or are close to a high limit for a certain time, they're capturing these events because later on, these events can be used for pattern recognition, right? So they can able to correlate that with the grades later on. And now for machine learning, what they did was they're using Python scripts and Microsoft Azure for machine learning, and they entered the model for the DCU into machine learning. I believe they run a random forest model to be able to have the priority of the variables that affect that particular unit. And this list basically what tells you is, well, which has the highest correlation with a particular event. In their case, the steam eruptions. And what they found was the RHC, or the residuals from the hydrocracker. And they also, if you see in the dotted line, I know you cannot see the number, but the number, it's about 10%. So they said, okay, so if we are over 10%, then we know that we're going to be on a safe zone. And that's what they were looking at. So now they know that they need to check on that variable, make sure it's over 10% within the mix into the DCU, and if they are, then they are okay to keep operating. So the estimated benefits of this predictive maintenance applications is about $230,000 per year at the particular refinery where they run this pilot. If we assume that this is the same for the other 6 refineries, well, you can do the math for me. But in 2016, actually, because of some initiatives like this and the digital transformation journey, they released a press release with a $1 billion EBITDA within the past decade, which is a lot. And for this accomplishment, they actually won the Petroleum Economist Award for the best downstream company of the year. So they want to keep working towards another $1 billion in 2030. So I'm really excited that we're actually part of that journey. So now, what is next? What happens with the data infrastructure? Where are we going? And hopefully this is going to give you an idea of what you are doing and what you will see coming. So first of all, at OSIsoft, we have a vision to go from the edge to the cloud, continue being your data infrastructure from the new IoT sensors that are collecting data in real time and connecting wirelessly to your plants, to the cloud where you can run advanced analytics off-prem and getting the results back on-prem if that's what you want to do. We also want to be able to connect the whole community. So it's not just about gathering the data from your plant or your refinery. It's connecting to your suppliers, even to your clients. How do we do this seamlessly and securely? So these are a couple of things that just happened and are happening within the next few months. So first of all, Analysis Framework, which is the tool that you all use to do the models, we just released a native integration with MATLAB. So I know that many of you use this tool for some analytics, some modeling. So now you can call some of the functions into AF and run the analytics also on at this server. Sigmafine, I saw this earlier this morning. You also released some thermodynamic libraries that will allow you to do more advanced analytics as well within AF. PyVision, we are focusing on making the usability more ad hoc and better for you to help you convert from PyProcessBook to PyVision displays. And this is coming up within the next few months. In terms of cloud technologies, OCS stands for OSIsoft Cloud Technologies. Right now, we are running CTPs for software as a service for the Pi system, and we are mainly focusing on partners that are doing data analytics in the cloud. So some partners are already using it, offering their solutions, and you can use their services to run some analytics on the cloud and get the results back into your Pi system. And at the end, the integrators, Well, we know that the integrators are helping us to push the data out of the Pi system into third-party applications. Like I mentioned, in the case of machine learning for Azure, we have an integrator to connect directly with Microsoft Azure. Later on, we are hoping to release an integrator for Amazon Web Services, which will be also another cloud platform. Of course, we are always looking forward to hear from you. So you can always send a message to feedback.osisoft.com, and this will put you in contact with our product management team. So to wrap it up, today I mentioned 3 things: the digital trends and challenges, big data. We have more and more information coming at us, and we can use the analytics to make sense of it. The customer success stories. In the case of Dow Corning, they have what I call a classic implementation of Sigmafine, where they are doing production accounting and yield performance in an automated way. E&I Versalis, they are using the composition tracking model to do the prediction of the quality going into the automatics plant. And in the case of MOL, they are using the real-time data and reconcile information to push that into machine learning models to being able to operate better and be ready for the challenges and the goals that they have for the next decade. So, and then the roadmap, edge to cloud. We want to be able to provide you with the information from the new wireless sensors that are coming at you to the advanced analytics that we know you want to do in the cloud. So we are working towards that goal. And at the end, I think for all the Sigmafine users, we just want to continue being and to have a better integration and a more robust platform for the powerful engine that you already have in place. This is my contact information in case you want to reach out to me later. I think I still have time for questions. So thank you.